Hello, I wanted to give you another example of the empirical rule. We've learned that the empirical rule, or in other words, the 68, 95, 99.7% rule, says that when we have a bell-shaped curve, the mean is going to go right in the middle. And if we go one step of a standard deviation down and one step of a standard deviation up, we can capture 68% of the data. If we go two steps of a standard deviation down and two steps of a standard deviation up, between those two values, we get 95% of the data. And if we go three steps of a standard deviation down and three steps of a standard deviation up, we get 99.7% of the data. So that's the basic empirical rule. The question though is, what if we're dealing with a problem, like we're going to be looking at here, where we're interested in two values that are an even step of a standard deviation above or below, but they're not the same amount of steps. For example, what if we were interested in one step down and three steps up? What if we're not symmetrical about the bell curve? So here's an example. In a mid-sized company, the distribution of the number of phone calls answered each day by each of the 12 receptionists is bell-shaped and has a mean of 49 and a standard deviation of 11. Using the empirical rule, what is the approximate percentage of daily phone calls numbering between 38 and 82? Okay. So, just looking at this first picture, we know the mean is going to go dead center. Now, I'm going to write these numbers above just because they have these little hints at the bottom and it's going to get too messy down there. Okay, so we know that 49 is going to go dead center. Are we all in agreement there? Okay, that is our mean. And it's going to go in the middle of this picture. And this picture is the same thing. The numbers that are listed here I'm going to explain in a minute, but I'm going to go ahead and write 49 dead center here also. Okay, are we with me so far? Then we have to start doing the steps of the standard deviation above and below. So in the problem, they tell us that a standard deviation is 11. So we need to start taking steps of a standard deviation of 11 above and below. So to get our 68% of the data, I'm going to minus off an 11. So 49 minus 11 is 38. I apologize, I have my daughter here. So we're going to put 38 here. And then on the other side, when I do 49 plus 11, I'm going to get 60. Okay? Any problems with how I got those two numbers? When dealing with the empirical rule, I'd always think about making this picture first before actually trying to answer the question. Okay, once you have the picture, it's going to be a lot easier. Okay, so 38 and 60. Now I'm going to go out another step. So I'm going to do 38 minus 11. That'll give us a 27. And if I do 60 plus 11, I'm going to get a 71. A bit too far there. Okay, so that lines up with the second set of blue lines. If it lets me move those, it will. Lines up there, and it lines up there. I'm going to just write the next ones in because it's being picky for me. All right, so if we do 27 minus another step of a standard deviation of 11, that'll get us down to 16. And if I do 71 plus another step of 11, that gets us up to 82. Okay, so I'm going to pause there for a second. Make sure you're agreeing with these numbers that I got. Okay, basically I started at the middle. I subtracted a standard deviation of 11, subtracted 11, subtracted 11 to get those three numbers. And then here I did 49 plus 11 plus 11 plus 11. Okay, that means 68% of the data is between 38 and 60. 95% of the data is between 27 and 71. And 99.7% of the data is between 16 and 82. The issue here is the question. The question is asking between 38, which is this value, and 82, which is this value. So they're asking, they're interested in two numbers that are not an even number away from the mean. They're not the same number of steps away. They're both numbers that we're interested in. They're all on the empirical rule list. They're in my picture, but they're not the same number of steps away. So basically, you need to break down the 68%, 95%, and 99.7%. And that's what this picture shows, okay? What this picture shows is they're using the idea that the bell curve is symmetrical. It can be folded in half. So 68 is this whole middle chunk, but that means since these two chunks on each side are symmetrical, they're even. So 68 divided by 2 is 34 and 34. Okay, so that's these two pieces of the puzzle. Okay, then from here, from 27 to 71 is 95%. So what we're going to do is we're going to take 95 minus 68, because the 68 is already accounted for in these two pieces. I just need these little tail guys here. Okay, so 95 minus 68, because I already counted that, gives me a 27. That means these two pieces together give me 27. So when I divide that by 2, that gives me this 13.5 and 13.5. So far, so good? Then the last step here is we know 99.7% of the data is between 16 and 82. So how much are these little tail guys here? Well, we've already counted 95 in the middle. So I'm going to take 99.7. I'm going to minus off the 95 for the pieces that we already have labeled here with these four guys. That gives me 4.7. That means this piece and this piece of the puzzle together make a 4.7. So I'm going to divide that by 2. And that gives me this 2.35 and 2.35 that are listed. And we could keep going to get these two pieces. Basically, 100% of the data is listed under here. So 100%, 100 minus 99.7, divide by 2. That would give us these guys, but we don't really need that for this problem. What we are interested in is we are interested in this guy, which is our 38, between this guy. Okay, so this was our 38 up here. And that was conveniently the number listed in the problem up there, and 82. Okay, so to get the percent of the data in between those two numbers, let me switch my color here, we are going to need this 34, because that's this piece here. We need this 34, because that's this piece. I'm trying to get the pieces between these two red lines. The 13.5%, because that's that piece. And the 2.35%, because that's this piece. So these four puzzle pieces make up the area between this red line and this red line. Okay, so if we go ahead and add up 34 plus 34 plus 13.5 plus 2.35, make that a little bit bigger there. Adding up all those values, I'll do that on my calculator. 34 plus 34, which we know is 68, plus 13.5 plus 2.35. We're getting an answer of 83.85. Okay, so that's the total percent of the data in between these two values that we were given. So if you're ever given two numbers that are not the same amount of steps about the mean, you're going to basically have to break it down into this picture. So this would be a convenient picture to make sure you have written down. Okay? All right, hope that helps. I apologize for the background craziness here, but I just wanted to give you an example in case you had any questions over that. Good luck.